Hey guys, this is Taylor here, and today we are solving the third problem of biweekly contest, which is minimum cost path with age reversals. Let's quickly read the problem. You are given a directed, okay, you're given a directed weighted graph with n nodes, okay, n is given to us, labeled from 0 to n minus 1, okay, and array ages where UVW, just typical graph problem, represents a directed age from U to V with cost W, okay. We know these things. Each node U has a switch. Okay, here comes a special part about this question. So each node U has a switch that can be used at most one time. Okay, super. When you arrive at node U, you have not yet used its switch. You may activate it on one of its incoming edges. Okay, we will understand deeply what we are this question is saying here. Reverse that edge U to V and immediately traverse it. Okay. The reversal is only valid for that single move and using a reverse edge cost 2 into W. Okay. Return the minimum total cost to travel from node 0 to node n minus 1. If it is not possible, return minus 1. So what we need to do, let me tell you. So here is the graph given to us in the question. This is the example one. In this graph, we have four nodes 0, 1, 2, 3, and we have certain weights. So what we can do, we have to move from 0th node to n minus 1 node, and n minus 1 is 3 here. So we don't care about whether we visit 1 or 2 or not. If there is a direct age from 0 to n minus 1, we can visit that also, and we can return that whatever x weight here. So x is our answer. So we need to return the minimum possible answer, minimum possible way to reach from 0 to n minus 1. Okay, so this is what we need to do, whether it's going from 1 2 3 or it's taking 4 5 or it's taking direct, no issue. How many nodes I can visit? I just need a minimum path. This is what we have to given. Second condition which is given to us is basically we can visit any number of nodes and we can apply operations also. So what that operation means is, if I apply operation on this one node, okay, if I apply operation on this one node, what I can do, any incoming edge, okay, so I think this is incoming edge, right? 3 from 3 there is one incoming edge which cost 1. What I can do, if I apply operation on 1, I can do like this. I will do incoming edge to outgoing and I will double the cost. Okay, I will double the cost. If we see this part, okay, so this was basically incoming edge to 4, incoming edge to 3 from 2. Okay, if I apply operation, let's say for example, if I apply operation on 3, what I can do, I can reverse this edge first of all and I can double the cost. Okay, this is what the operation looks like. So any incoming edge coming to this node, I will reverse it and I will double the cost. This is what given to us. This is the operation that I can apply. And let's say ki on this one node, there is multiple nodes, multiple edges coming. I can apply only one time. Okay, I can apply this operation only at one time. Okay, superb. I hope question is clear to you. Now let's talk about the intuition, how we can basically solve this problem. So if you see, this problem is much related to the single source shortest path algorithm. So what we need to do, we need to find the shortest path from 0 to n minus 1. So when I heard this thing, okay, we need to find the path from 0 to n minus 1. So the first thing that comes to my mind is Dijkstra algorithm. But the point is, here we have this operation wala thing, and this operation wala thing requires some changes, and this operation wala thing can change my shortest path, because I can directly reverse the edges by doubling its weight. Okay. Okay, so let's talk about the intuition to this problem. Okay, so here we had graph, right? We had discussed, okay, how we can, what we need to do. We have to visit from 0 to n minus 1, and whatever no path we have to take the minimum possible path. So I have this bigger example. In this bigger example, we can discuss the intuition, like how to come up for a solution for this problem. If you understand the intuition properly, you will definitely able to code it without seeing the approach. Okay, so let's talk about the intuition. So intuition is basically that I am currently at 0th node. Okay, so I will definitely start from 0th node. Now from this 0th node, there will no incoming edges. If there is incoming edges also, I can directly ignore it. There is no issue. So I can visit to first, okay, node 1. I can visit to node 2. Okay, this is the two nodes I can visit, right? And what is the problem that I need to solve? I need to reach the last node. I need to reach the n minus 1th node. Okay, so what I can do, like to reach, there is no direct path from 0 to n minus 1, right? So I need to just carry forward. I need to just move some forward direction, right? And forward direction is only 2, 1 and 2. So let me move. Let me move. So let's suppose that I have moved in this, okay, in this one, okay, or I can consider parallel also. So I have moved to 1. I have moved to 2. Super. Now from this, what I need to do? I need to carry forward. I need to just forward now. Move forward now, right? So like there is no incoming edges. There is no incoming edges here. I don't have to apply any operation or just keep things simple. I will just move forward. Okay, I will just move forward. Super. So from what I can move here 3. From this one I can move either 4. From this 2 I can either move to 5. Either I can move to the 6. Okay. So okay, I am in this range. I am in this range. Now I can see that in this range I have this reversed edges. I have this reversed edges. I have this forward moving edges. Forward moving edges. Okay. So let's suppose I am here. I am at 5 and I need to visit 7. Okay, I need to visit 7. What is the cost currently? What is the cost currently to reach 7? I think if I visited only this part of nodes, cost to reach 7 is infinite, right? Infinite. So what I need to do? I need to visit, and I am getting some cost 1 plus 2 plus 4, 1 plus 2 plus 1, which is 4. So I am taking 4 cost to visit 7. Can I visit this? Yes, definitely I will visit this. Similarly, 8. I will definitely visit via 6, and I will like whatever cost is 3 plus 1 is 4 and plus 10 14. So I will definitely remove this the infinity and I will just make 14 and I will remove this 8th node. Okay, I will remove this. I will move, I mean, visit this 8th node. Okay, similarly, let's see. So intuition comes here. Now, I can see that I am at 3 node and there is no outgoing edges. There is no outgoing edges, right? There is just 2 incoming edges. So if I somehow know that whatever what all incoming edges are coming to 3, and if I can remove this, I can remove this and I can go to 9. Okay, and we are double cost if I can go to 9. So that's why I can apply the operation and I can visit 9, right? I can visit 9 and cost to reach 9 is infinite, let's say infinite. And if I remove this, so 1 plus 2 plus 1 into 2. Okay, so 2 plus 1 is 3 and 3 plus 2 is 5. So I can reach 9 at a better cost of 5. I have removed this infinite. I can reach at 9 with a cost of 5, right? Let me again explain you. Okay, so 0 to 3 it's fine. Okay, 0 to 3 is fine. Let me draw the table also, that will be help us. So this is 25, 9, 11. Okay, all of the costs are infinite. Now to reach one, I think I can definitely take a cost of 1. To reach 2, I can directly take cost of 1 again. Now to reach 3, I think 3 is the cost, minimum cost. To reach 4, I think 4 is the minimum cost. So I'm not going in detail like how I'm feeling this. There is one prerequisite to this question, which is I am considering that you know Dijkstra algorithm. So with Dijkstra algorithm, we can directly compute this distance array, yeah, and we can find the shortest graph. Okay, I'm just explaining you how to utilize, what is the intuition behind this this reverse stage wala thing. Okay, superb. So I think the cost to reach 5 is again 3, the cost to reach 6 is 3 plus 1 4, and cost to reach 7 is I think 2 plus 1 3 and 4, and cost to reach 8 is 14. Super. Now we were talking about 9, right? So there is no way to reach 9. There is no way to reach 9. But if I somehow know that, if I somehow know that there is one incoming edge from 9 to 3. Okay, 9 to 3. From 9 there is one incoming edge to 3, which cost is 1, which cost is 1. So I can consider that, I can know that from 3, I can reverse it. I can reverse it, and via 2, I can visit. If this 2 is smaller than this infinite, I can directly update this, right? Definitely, I will update this. Let me update this. So 2 plus 1 is 3. 3 plus 2 is 5. Why 5? Because this cost, this becomes actually like this, and cost become 2. Okay, cost became 2, right? I can cut this. Superb. Superb. Now 9. Now I'm at 9. Okay, I'm at 9. Okay, let's talk about this 4 first. So Do I have any way to visit 10? No, I don't have. But there any incoming edge to 4? Yes, there is one incoming edge. So can I reverse it? Can I reverse it? Yes, definitely I can reverse it. So I think the cost was 2. But if I reverse this, I think the cost will be 4. And whatever the cost to reach 4 is, I think 4 is taking 4 and 4 plus 4 is 8. So 8 will be the new cost to reach 10, right? To reach 10, I can take 8 cost and I can directly reach the 10. So I got something better. Infinite is like not better, right? For this 8 is far better than infinite. Definitely I will take this. So I just need to, the intuition behind solving this problem is we just need to maintain reverse arrays. Okay, reverse edges. If we maintain reverse edges also, na, so that will help us at any node. If there is only incoming edges, so that reverse edges will be pointing like this. So I know that if currently at 10 I'm having infinite, and if I having reverse edges also, I can know that I can visit 10th node with some weight, okay, some finite weight, which is definitely better than infinite. So the whole idea behind solving this problem is only this thing, that we can maintain the front edges, forward edges, and reverse edges both at the same time. And every time we will just check that whether we can visit the distances in minimum possible cost. So we will definitely apply just simple Dijkstra. But when we were traveling through the neighbors, now when we were reaching the neighbors, we will just check whether the forward edges or the simple adjacency list are able to give us minimal cost, or the reverse edges are giving us the minimal cost. Okay, so let's complete the diagram first here. So I am at 9, and from 9 there is no outgoing edges. Okay, so like there is one outgoing edges 3, which is I don't want to go reverse direction. Actually I came from 3 to 9, so I will not move from 9 to 3 again, definitely. So I can see that there is no outgoing edges from 9. So but there is one reverse edge, but 20 is the cost. 20, how, why 20 is the cost? So I will just double it. I will just reverse it and I will double it. Okay, so I have doubled it. And what I got is I think I got something like this, and cost is 20. I can remove this. I can remove these two things. Okay. Super. So what is the cost to reach 11? I think 20 is the cost. Yes, 20 is the cost. Now here 4, I am able to reach 10. Now, is there any way to reach 11? Yes, there is a way. There is a way. What is the cost to 8? 10. I think 8 is the cost. And to 11, I think I am able to reach at better cost. So I will make it 10. Super, super. Now, from 7, okay. There is also a way to reach 11. How, what is the way? I think I can remove this. I can make it 20, and I can reach from 7 to 11, right? So I hope this intuition is clear to you. So what we need to do, we need to just maintain the forward adjacency list, normal adjacency list, plus the reverse adjacency list. Okay, reverse adjacency list. And what we need to do at any point, let's say I am at 4, I will check this list whether like are there any outgoing edges from 4 to 10? Yes. So directly move. If there is any incoming edge, let's say from 11, so I will try to reverse this, and by doubling the weight, okay, and I will try to visit 11. If there is better cost, then definitely I will visit. Otherwise, I will discard it. Simple. Okay. So I hope the intuition and approach is clear to you. Let me write the pseudocode for this. So pseudocode will be very simpler. What we need to do, we need to first create. Let's talk about the approach first. So create the normal adjacency list. Okay, first thing we need to do. Second thing is create reverse adjacency list, because we'll be using both of these things parallelly, both of these things concurrently at every step. Okay. Third thing is um do a simple Dijkstra. Okay. And fourth thing is like just check in the last minute, just check we are able to visit the last node or not. So this problem is really, really simple. If you are not able to understand fully, once I will write the pseudocode, you will be able to understand it fully. But you can pause the video now and you can try to implement the solution. I have told you enough intuition to get started by writing the code. So just make sure you write it yourself because that's the only thing you will be able to learn. Once you write the code, you can come here and check whether your approach is optimal or not. Okay, and pause the video and go ahead. So let me write the pseudo code for you now. So I will just try to define something like this adjacency list of this. I'll create empty list. Okay, empty list of size n because n is the number of nodes, and I will create the same adjacency reverse list. Okay, and I will copy the same thing empty lists. I don't think I need to explain this thing because I'm considering that okay, you guys know Dijkstra algorithm. Okay, if you don't know, you can just search on Google and you can learn that thing first, and then you can come here and understand this. Superb. So I need to create this and create this. So I think creation will be simple for u, comma v, comma w in ages. I will be I will be going through all of the ages. Okay, like ages arrays like this, na. So at a time, I will take U, V, and W, and I will do certain operations on them. What is the operations? So adjacency list of U dot append. What I need to append? I need to append V comma W. Super simple then. And second thing, what I need to do? I need to append in reverse adjacency list also parallelly. I will append this time in V, okay? And what I need to append, just carefully see. I'm appending U, comma 2 into W, okay? Because my cost will be doubled. Super, super. Now, this is just a simple Dijkstra, so I will make a distance array of, let's say, all nodes will be infinite in starting and distance of 0 will be 0 because I know one thing for sure that I will be starting from 0th node, okay? Now, what is the next thing? I need to maintain a queue. In that queue, I will maintain this 0. 0 is a distance, comma 0. This 0 is a node. Okay, this is node and this is distance. Super. So I will just try to iterate over this queue while queue is not null or none, whatever you say. What I need to do, I need to take the distance, comma node from q dot pop, whatever you say, and now what I can do, I think I can visit the neighbor nodes for neighbor ngbr neighbor, comma distance, neighbor distance. I think I should make ngbr distance in adjacency list. Okay, this time I'm using adjacency list and I'm using the node. Super. So what I need to do, I need to check whether this distance is okay. Distance to reach neighbor equal to minimum, okay, or let's write if else condition for better clarity what is happening. If okay, if distance distance to reach node, okay, distance to reach node, let's say x, distance to reach node plus distance to reach neighbor, okay, neighbor distance is less than distance to reach neighbor. So what we are doing is basically that let's say I am having certain node here, okay, some two node, and its distance to reach is currently infinite. So if I'm reaching x, let's say I'm reaching with 2 and from here I am reaching at node 1. So this 2 plus 1 is 3. So that's what I'm checking. This 2 plus 1, okay. So this distance 2 plus this one neighbor distance 1 is less than is infinite, right? If this less than infinite, so what I can do, I can definitely update my distance to each neighbor. Distance of neighbor equal to this distance plus neighbor distance. Super. And if this is the case, if I'm going in this inside this if condition, if you know Dijkstra well, I don't think I need to explain, but still I'm explaining. So I need to append q dot push. This q is heap q. Okay, this is mean heap. Okay, so I need what I need to push. I need to push this distance first of all. Okay, distance of neighbor, updated distance, comma the neighbor node. Okay. I don't think I need to explain these things in much detail with Byron because I'm considering that you know Dijkstra algorithm very well. For neighbor, now I will be using the reverse adjacency list. Okay, so neighbor distance in reversed. Okay, reversed adjacency list. What I need to do? I need to do the same thing. This same thing will be copy pasted below. If distance plus neighbor distance is less than distances of neighbor, I can visit it. Yes, distance of neighbor equal to distance plus neighbor distance. And I can definitely push it to Q because I got something better. As soon as we got something better, na, we need to push it. Neighbor, comma, neighbor distance, comma, neighbor. Superb, superb, superb. And last, we can check if distance of n minus 1 equal to infinite. If it is the case, then I can return a -1. Otherwise, I can return whatever distance present in that node. I hope you got the logic, the intuition, and approach how we will be solving this problem. I think the intuition is not very tough. In fact, this is kind of easier than second problem if you know the Dijkstra algorithm very well. Okay, so let's create the adjacency list. Adjacency list will be I will be using this for underscore in range and one thing guys, just one tip. So when let's say I'm creating this reverse adjacency list, and let's say if I create something like this, I will tell you that don't do like this. Okay, don't do like this. I have faced like I think 2 years back I have faced this issue. If you create like this now, so if you let's say if your array looks like this, let me tell you, this is very important. Never do like this. So if you create array like this, a single array, then that there will be no problem. So whatever zero in it's specifically to Python. Okay, if you write in C++, Java or JavaScript, you can definitely skip it. So if it's specifically for Python, guys. So if you want to, let's say, create a 0 0 0 0 0 n times array, you can definitely use this part, okay? But if you, let's say, you want to create a 2D array and 0 0 0 and 0 0 0 and 0 0 0, okay? If you want to create this array, so never use this. Never use this, okay? Never use this. Why? Why? Because what is the thing? If you use something like this now, so this same array will be reflected everywhere. So let's say if you update this value now, so value of this and value of this will be also updated. If let's say you update this to 2, so this 2 and this 2 will automatically update because inside Python what it is using the same list pointer to every column, every row. Okay, it is using the same list for the every row. So that's why it's highly recommended not to use this thing. Okay, so just use this for loop. This for loop will work better and will solve the purpose. Okay, so we have created this. Now from U, V, and W in pages, what we need to do? I think we need to create the adjacency list. So adjacency list of U dot append, and what I need to append, I think I need to append the what is the node I can visit and what is the weight. Super. And the same thing I need to do for reverse adjacency list, but this time I am visiting the V node with, and from V node I can go to U with a weight of 2 into W. Super, super, super. So this is basically the part where we are creating adjacency list, adjacency and reverse adjacency list. Super. Now the things are simple. Just uh, traverse using Dijkstra and find minimal path and use both adjacency list and reverse adjacency list. Superb, superb, superb. So I will be using my distance array like this. So float infinite into n. So this like this I can use, but nested list never create like this. Okay. So distance of 0 will be definitely 0 because I will be starting from 0. Now I need to use something called as heap, mean heap. Okay, so I will define my mean heap as like this, mean heap equal to empty list and heap q dot heap push. And what I need to push in mean heap, I think 0 comma 0. That means 0 is the distance and 0 is the node. Okay, super. Now while mean heap is not none, what I need to do, I need to uh, mean heap q dot heap pop. I need to remove the minimum heap, minimum distance, mean heap comma. I think mean heap is sufficient. Now I need to visit the neighbors from neighbor comma neighbor distance in I think adjacency list of node. I will be using the forward traversal, then the reverse traversal. Okay. So what I need to do, if distance plus neighbor distance is less than distance to reach neighbor, then I can definitely update this, right? Yes, let's do it. Let's do it. Yes, super. And in that case, what I can do, what else I can do? I can push with q dot hip push, and I can push the this distance of neighbor, the new distance, and the neighbor. I think this is just simple Dijkstra. And let me copy paste this similar code here itself. And what I will be changing, I think just this thing, adjacency list, I will be using reverse adjacency list. And everything will be same, totally same, no issue. In last, what I need to check, if distance of -1 means n minus 1 node is equal to float of infinite, means it's still infinite, then I can definitely return -1. Otherwise, I can return uh, whatever the distance present at that. Okay. Let's try to run this and see whether it is working fine. Here we got some invalid syntax for underscore in range. What is the issue here? Okay, I missed this equal to here. I was explaining you that term, right? That's why I forgot that. I think yes, return -1. What's the issue here? Outside of function? Oh, okay, okay. Let me indent this. I think now we are good to go. Let's try to run this. Super. It is working fine. Let me try to submit this and see whether it is working fine or not. Okay, it is working fine. So I hope you guys are able to understand this, and the only intuition for solving this problem is only this reverse wala thing. If you understand this reverse wala thing, that every point, I need to reach this 10, okay? And if there is reverse it, okay, I can reverse it and I can visit this 10 via double cost. So why not to visit that node, okay? That's the only intuition behind this problem, and I hope you are able to understand it properly. If you still have any doubts, please make sure you comment down and I will definitely solve this. And thank you very much guys for watching this video. And if you understood, please subscribe the channel so that that will definitely motivate me to create more such insightful solutions. So with that, thank you very much guys and we'll meet in the next one. Thank you.
Hold me close till I get up. Time is